Hey everybody, I'm Keith. I'm an Android engineer at Square. I currently work on our design systems team. So, if you ever heard about Material, Google's design system, we have something similar like that at Square. We call that Market. And today, I'm going to talk to you about reimagining Android dialogues with Compose. So if you're unsure what that means, um, let's think about as a developer when you reach for a dialogue, what do you think about? Maybe if you're a seasoned Android engineer, you worked with this thing called Dialog Fragment. It was a rather large class that you had to instantiate, but it had back handling done for you. Or maybe you are very interested in Compose, um, or maybe you're a new engineer and you've seen this thing called Alert Dialog. And underneath the hood in Dialog, you see there's some setup with the dialog wrapper and the dialog layout. And so, what the dialog wrapper is essentially like an abstract composed view. And what these two have in common is they both open up a absolutely new window. So this is during the dialogue creation. What's happening is you grab this Window Manager service, you save an instance of that, you create an absolutely new phone window. So there's a lot of setup just to show an Android dialogue. And at this talk, we're gonna talk about how Compose completely changed that. We're no longer showing a new window. We're doing everything in Compose, and that's what this talk will be about. And to help me do this, I'm going to talk about how we even got here and why we even decided to work on this problem, and how Compose overlays came about and how it helped us in many ways that we didn't think that it could help us. We'll look at how they compared to the old dialogue to our thing, which I'll refer to as Compose overlays, and talk through what this unlocks for us as devs. So that means better performance, fewer leaks, easier testing, and consistently working previews. Um, I'll also walk through some the internals because parity mattered a lot. The window gave us a lot of properties, and we needed to rebuild those. And then I'll show you what it looks like in real apps. So I'll do some demos, some live interaction, and finally I'll share at the end what we're thinking about with Kotlin multi-platform and open sourcing. So how did we even get here? Well, Market has a lot of this flavor of dialogues. And dialogues are seen at really crucial point in your user experience. For example, at the far left, we have this example of what we call a partial modal. And this modal is showing for the user that it is about to sign up for a subscription. Um, Another thing, a user can do something destructive. So you can pop up a bottom sheet. So a bottom sheet is like another dialogue. And then you have popovers. So maybe you have a complex screen and it needs more real estate. And so you think about showing a popover. And so there's a lot of, these are just a subset of dialogues we had to maintain. We have other different flavors of what dialogues would look like. Um, and over time, these sets of dialogues started to break down for us. And here's like what we started noticing. First, dialogues require all these interop. So you have to launch a compose view to then show your composed content within it. We had to drop back into views just to show something simple. And this introduced performance costs because we're asking the system to open like a whole entire new window. And then came animations and styling. So with all these different flavors of dialogues, they have different animations, how they animate in, how they animate out, how they would interact with the scrim. So maybe some would not have a scrim. So the scrim meaning like the dim gray background, which you would see in a normal dialogue. And then that's not only it, but we saw fragile support for previews. So some things would break down when we did like composed library upgrades. And then, of course, everyone is familiar with memory leaks. Um, And so I'm going to talk about these first 2 points first. And in order to help me do that, I think it is really important to understand what exactly is happening when you call dialogue show. So I'm not expecting everyone to remember this. This is a lot, but this is just to show that there's a lot of stuff going on just to show a simple window. So at first you have this dialogue creation, and it saves an instance of this context. It then grabs this window manager service and saves an instance of that. Um, and that creates like a new phone window instance that you saw in that previous slide in the very beginning. So that was just creating the dialogue, and now showing it. You have you have this you have this window manager, and you can add this view, um, and the core view is instantiated from the phone window, and then this is like where the styles are applied. Um, then with the window manager, it has like its own properties that's happening. So um, it instantiates an IPC call because you're grabbing this window from this window manager service to get like this actual service. It creates a view root impl, which is like this huge orchestration class that kind of is the glue between view and the window. And the view root is like has its own responsibility. So it sets a root view and connects it to a surface. It registers in a new choreographer, so that means it has to manually drive the measure, layout, and draw. And this is going into the hood. So when you have a bunch of services that you are backed by buffer queues, and then you send all these services to the surface flinger to actually make the actual rendering that you see on the screen. And last but not least, the most important part is tearing down your dialogue. So if you don't do that, of course, there's going to be some memory leaks. And this was like where surface released, and that was a lot just to show a simple window. And at some point, you have to stop and ask, like, why is something so common still complicated? And that's when we decided to build compose overlays. Essentially, a system designed to give you everything dialogues do, but built for modern UIs, built for the way modern UIs are designed. Um, so the core concept of this to understand is that this is for app level dialogue. So if you want to show a dialogue outside of the app content, then this library wouldn't be very useful for you. And so if your app, if your dialogues stay within your app content, then this is going to be very useful for you. So essentially, underneath the hood, Compose Overlay is just leverages Compose completely. So it shares the same UI with all your other content. So that means they share the same composition, layout, draw phases. There's no separate window, no special life cycle. Completely powered by the Compose runtime. So you get recomposition, state observation, animation APIs, and hoisted state all for free. So in essence, we are applying a box on top of your existing content. Sorry, let me go back. But how does that actually look in code? And what do you need to hook up to start using this in the real lab? Let's break that down, and here's how our overlay system works at a glance. So, Compose Overlay has this overlay manager. So it sits at the top of your root content. And is responsible for rendering all the active overlays, which means it's part of your normal composition. And it is driven by a mutable list of basically Compose overlays. And this allows us to have multiple overlays at once. So you could have like a she and a dialogue and maybe even a popover on top of that dialogue. All that would be supported. And to echo, this is all app level. So it's perfect for dialogues that stay within your application window. The final thing here is that it is required for you to enable edge to edge. And this is really important because we wanted to react gracefully to the keyboard software input mode. So we needed to leverage things like modifier IB padding and the other like padding like modifiers that Compose gives us. So hopefully you have a better understanding of how Compose overlays differs from traditional dialogues, especially how they're like declared and rendered. So let's put that to the test and see where the performance actually looks like. Oops. So we took this real world example of a user entering like maybe their favorite quote, choosing their favorite color, and we ran macro benchmarks on our real physical handheld Square device. It's like our newest device. And so we ran 50 iterations of benchmark, and you can see that the numbers from Compose to Android Dialog are very different. So the P95, the P95 for Android Dialog is at like 43.2 milliseconds for a frame overrun, whereas Compose it's 34 milliseconds. And so what we're seeing here is that Compose Overlays consistently hits the frame budget more reliably than the old system, even under the same layout and input pressure. And to help you see, like that was a 26% faster frame rendering for Compose and 35% lower frame overrun with Compose. And that's a win for every frame your users will see, and it compounds on slower devices. And we were like, well, these numbers look pretty good, but maybe we can do another test with something a little bit more complex, like our bottom sheet that we completely rewritten in Compose. And so a user launches a bottom sheet, taps on the button, and then moves on with their day. And so we ran another 50 iterations on this bottom sheet. And we see with Compose, the P99 was very stress tested, stayed under 60 milliseconds, whereas the Android Dialogs is at 70 milliseconds. And this wasn't animation heavy at all. It was just opening up a sheet and tapping on a button. And we saw 24% faster frame rendering and 34% lower frame overrun. And so like these performance numbers look good. And then you have to remember like, well, we are no longer showing a new window, which means, well, what do you think? Less memory allocation, right? So we did a heap dump on our Compose versus our sheet. And we see a 14% reduction in shallow heap size. 150,000 fewer objects created, and much fewer classes loaded, including like the view related ones. So with Compose Overlays, we reduced our shallow heap size by over 3 megabytes, while also reducing our class and object count. And that translates to lower garbage collection pressure, faster cold starts, and fewer risks of memory leaks. So if you like pop open your app and maybe you show a dialogue for a user to update, their app, that dialogue will show much faster. So that's really great. We were able to see like performance and memory benefits, but that wasn't the only thing we were fighting. We were also fighting with animations and styling. So we had all these flavors of dialogues. They had all their different XML code. Maybe there was some animation code in some Java or Kotlin class. We weren't, and then having to be in like Compose and then going into XML was just like not something that you would want to do. We weren't building modern UIs. We were like reverse engineering like 2015 Android. So let's talk about styling and why Compose gives us a tool that we actually need. So with Compose Overlays, you say completely goodbye to XMLs. So no more setting up like this archaic kind of like XML layout. Like there's a duration, but then like there's different tags, so it's just like not the easiest thing to read. And so we completely revamped that, and we drive all of our animations via modifiers. And so this is pretty great because given that we can all use modifiers, we can leverage things like graphics layer, which completely optimizes and only runs the draw phase. So you know how Compose has the 3 different phases, and we skip all those phases besides the draw. So just animating in your dialogues and animating out your dialogues are just going to be much more snappier. And given even things like with a crossfade composable animation, you couldn't crossfade to Android Windows. It's just a very complicated problem that I think Google is still trying to figure out. But with this all being composed, like we can use crossfade because it's just composables. So animating in one dialogue for another is just something it's just very easy. And so, given this is all driven by modifiers, our code became a lot more readable. It stayed within line of our code. Like we're not looking at our dialogue code and then seeing like, oh, this is XML. Let's go to XML. But maybe that XML referenced another XML. So it's just a lot of hopping through. So having modifiers really helped us better maintain our complicated dialogue code, our complicated animation code. And so, modifiers gave us a really huge benefit, and I'll go into deeper how using modifiers helped us do other things. Another point that we kept running into at Square is we would sometimes show a dialogue and it would have like an error when doing a screenshot test, or we just get an error in previews and we're just like what happened? Like, oh, we updated the newest Compose library, so maybe it could have been a Compose library issue. So the old existing way, the previews were fragile. So as screenshot failures, like Roborazzi had issues, Paparazzi had issues with representing dialogues in their screenshot tests. And so window is the issue. And yes, many of these bugs were fixed, but like that's the point. We shouldn't have to wait for a fix to hold us back, hold us back for like a tool upgrade just to keep a dialogue test working. Compose doesn't fight the Compose model; it embraces it. It's all Compose, which means better previews, cleaner tests, and less CI fragility. And so, there's Compose overlays. Doesn't rely on this fun window. So tools like Paparazzi and layout preview, they should just always work as expected. And if it isn't, then it's likely a Compose issue, and that's a much bigger problem. So with Compose overlays, you should no longer have to worry about these issues with on a Google issue or a GitHub issue. These tools will work reliably. No mucking or flaking. You have less flaky tests because you're not opening up a new window in your UI tests. And the power also, what I brought up with modifiers is, take for example, there's this Android dialogue. There's no way to see what this will look like at like half the progress. Whereas with Compose overlays, we can do that. We can see where our dialogue would look like at half the progress, or maybe 75% of the progress, or even fully, to where it's rendered onto the screen at one flow. And not only that, but we can represent how our overlays look like on our previews when they're stacked. So I can have like a partial modal, which is our flavor of our dialogue, and then like an actual dialogue that everyone knows. And so we're able to fully like see this in a preview. You'll be able to see this in your screenshot test and really have no issue. And then finally, everyone knows about memory leaks. So the old dialogues are prone to memory leaks. You had to make sure that you dismiss them, which is often like a big mistake. dialogues hold a context and they're not dismissed explicitly, you will get maybe this fancy issue. Or maybe if you use Lead Canary, maybe you've seen issues like these. And these are like production on our CI. Like we had so many memory leak issues, and it was just pretty frustrating because it was hard to see where the memory leaks were happening. Like, was it in Compose? Was it in our implementation as a design system, or was it our feature engineers? Were they holding on to the context longer? And so, you know, you will no longer see any context leak. No, don't have to worry about dismissing calls. Maybe you will have to worry about updating your mutable state so that it can like hide the overlay. But this has no windows, no need to save lifecycle aware code or anything. And so we published our we launched our Compose Overlays project on one of our kitchen displays team, and since that's in production, we have not seen a single memory leak, and that's been pretty awesome for us to see. Okay, so we made it through all the pain points and how Compose Overlays help solve a lot of our issues. But maybe you're like, Keith, isn't this just putting a Compose box on top of my content? Like, how is this so hard? Well, I thought that too. And at first, I thought it would be as simple as slapping a couple boxes and calling it a day. But once we tried to match the system dialog, what it really gave us, like touch blocking, keyboard insets, this wasn't just UI, it was infrastructure that we had to build for it. And we had to mimic all the window benefits that the window would have given us. So again, like these may look like table stakes, but Compose never gave us this for free. So rebuilding things like touch path strews, so preventing touch input. Say like you have a dialogue and you tap on the scrim and you see the content, like that should nothing should be clicked. It's only the dialogue that is shown. Now the thing is accessibility readers. It should only stay within on top of the window. It shouldn't go below to the content when there's an overlay presented. Then soft input keyboards. So if you are familiar with the soft input mode, there's like adjust pan, there's adjust resize, different way that your window will react to the keyboard. And so we help build the adjust pan and the adjust resize. And then these last three, supporting multiple dialogues. We rebuilt completely our bottom sheet fully in Compose, and also our popovers. So everything we covered, just all in Compose. So I'm going to jump into some demo to kind of give you a feel of those things that I thought were table stakes. So let me jump into changing my entire screen. Okay, so this is a quick demo. So I'm going to demonstrate that the clicks should not go through when an overlay is presented. So when I tap on an item, a dialog is going to show, and I'm tapping around on item 0, item 1, and nothing is happening, and that's what we expect. Then I'm going to pop open our accessibility reader. I'm going to tap on an item again, and you see that the focus was brought from the lower content onto this overlay. And if we swipe through, it stays within the window. It doesn't go below to the content. So let me remove accessibility. Okay, so now let's see the demonstration of the keyboard input. So say we have this really awesome looking dialogue, and currently it's in adjust pan. So what you expect is just the field to be a common focus. So let me turn on your keyboard, and you see that the dialogue is so big, but it focuses just on the field. We can close this dialog and move this to resize, open up the dialog again, and then you see that window completely resized. It doesn't just bring the input in focus. It resizes the whole window, which mimics the soft input mode behavior that dialog windows would have given us. Next, you have our sheets, and I can demonstrate showing multiple overlays. So here I showed a composed overlay sheet, and I showed a dialog over it. You can see that when I resize, it doesn't resize the entire content. It resizes just the window itself, and that's something that you could change if you wanted. So it's very flexible library. And then last, we have our nested interop. So when you are scrolling on a sheet, when I get to the top of the list, it should also scroll down our sheet. And that's it for the demo for all the table stakes that we thought. Or there's also popovers. Do a little quick example of like a popover. This is all composed overlays, so I can like drag and drop this everywhere, and a popover would be anchored onto the element. So you can anchor this popover on any composable element. Okay. So, everyone sees my speaker notes. And so all this is just composed. So what that means is that we can hook into Kotlin multi-platform and then be able to share our UIs with desktop, Android, and iOS. So we've been working on a composed multi-platform library, and I'll do a quick demo of that. So this is an example project of a quick Kotlin project that demonstrates our sheets and Dialogs. So here you have our sheet on iOS. You can be able to scroll, see the nested interop work as expected. You can, or something happened. Oh no. Let me do the back gesture. No. All right. So, okay, that is not working. But you can visualize that like all this stuff still works on iOS, and then we also have a Kotlin project for our desktop app. So here we can see a popover work on our desktop app. We can go and see a dialogue on desktop, and even our compose sheet. We can drag and drop our sheet off the screen. And so hopefully this highlights that given that this is all composed, we can share all of our dialogue infrastructure using our composed multi-platform library. And with all that being said, we plan on open sourcing this library. It's very top of mind for us, and definitely be lookout in the next month for us releasing this out to the public. So hopefully that was really fun and engaging. What we learned today was we mapped the pain points of legacy dialogues, why dialogues matter, and why a phone-based window once held us back. I introduced composed overlays, no phone window, no system window manager, all just compose. It's faster, safer, more customizable, reduced memory leaks, improved testability, and enabled us to have really powerful animations, but have those animations be very readable and digestible. We built every expectation. So what the window gave us, we rebuilt it all in Compose. From touch blocking, accessibility, bottom sheets, popovers, UI testing. I did some live demos and showed you about our Kotlin multi-platform support. It works on Android across all platforms and real apps. And open sourcing is on top of mind for us. And so you can use this in your app as well. Thanks for coming to my talk, and that was engaging. and I can open the board for any questions. I think there's a mic over there, but if not, then I hope everyone has a cool rest of your day. Sweet. Oh, maybe in a month from now. Been very busy working on this talk. You want to jump in? Oh man.
Which which overlays are currently supported?
So the current supported overlays are bottom sheets, popovers, dialogs, and when we open source, we're working on rebuilding Toast. So if you have any problem with Toast, we're also working on that. So you can have multiple toasts at one time, and maybe toasts are very ephemeral. So if one disappears, you would expect the toast to animate down if there was multiple toasts, and so we'll be working on that as well. Thanks. Sweet. I think that wraps it up. Thank you, everybody.